Let us now discuss the concept of thermal conduction before steady state. When we talk about a material of which the two ends are at different temperature, T1 and T2, and the rod is also at different temperature, then we have discussed that it takes some time when the rod will be in a steady state. Then in this situation, when we consider a small segment AB in the rod, and say from one side at an A, an amount of heat dQ1 is supplied, then a part of this amount of heat dQ1 is used in increasing the temperature of the segment AB, and as its temperature increases due to supply of heat, it will further contact some amount of heat dQ2 to the other segment of the rod. And always here we can say dQ2 is less than dQ1 as a part of dQ1 is absorbed by segment AB. Now in this situation the temperature of AB will be raised up to a limit when the temperature gradient in the whole rod will become constant. Once the temperature gradient in the rod becomes constant, a steady state will be arrived and no more further absorption of heat takes place by any segment of the rod that we already discussed. So in this situation here we can say dQ by dt, here if we talk about absorbed by the segment AB, this must be equals to dQ1 by dt minus dQ2 by dt, that is the rate of flow of heat in form of conduction from point A and from point B. Now in this situation here if temperature of segment AB increases by dt in time dt, this implies here we can write the value of dq will be equals to ms dt, where ms is the heat capacity of the segment AB. And here in this situation if dt by dx A and dt by dx B are temperature gradients at points A and B, then here from this relation 1 we can write dq by dt, we can write ms dt by dt, this is for the segment AB, that is rate of rise of temperature of segment AB. This can be written as dq1 by dt, here we can write ka dt by dx at point A minus ka dt by dx at point B. And this consider when thermal conductivity of the segment will be relatively high, so that here we can write when temperature gradient at point A is dt by dx A, so the amount of heat conducted per unit time will be ka dt by dx, and similarly at B it is ka dt by dx B. When a steady state is arrived, these two temperature gradients become equal, or we can say throughout the rod temperature gradient becomes a constant. In that situation, this rate of rise of temperature of the segment AB becomes 0, but until the steady state is arrived, this relation gives us the relation between temperature, rate of rise of temperature of segment AB with the temperature gradient at the two ends of the segment at point A and B.